Hello there, it's Jay here from Jay's Vintage Junk, and today we're back on with this Solatron HT PSU, and I've got the circuit diagram for it here. I actually managed to find the circuit diagram. See if I can just perhaps zoom you in a little bit, see if you can see this thing. So it's rather difficult for me to see what you can actually see, but never mind. Right, it was reasonably tricky to find any information on this. There's not a lot of information out there. I do know it is from about 1960, and I think they made them up till 1962. It was described as a schools and military lab power supply. It was designed for military use and educational use, and apparently there's one of the few comments I found about it was that it was tough enough to withstand like student abuse. So they were obviously a decent, well-made unit. It's probably why the military used them as well. The circuit actually is really quite simple in it. Basically, I'll quickly go through the circuit as best I can and explain how it actually works. We've got 3 rectifier diodes, and these are just single rectifier diodes. We've got 2 in parallel, and then 1 down here on its own. And we've got 2, I think they're tetrodes valves there. They're like a beefed up pentode type valve. They're what's used as transmitting valves and output valves and things like that. And so basically what we do, our main high tension comes along here. It's rectified by these 2 rectifiers in parallel. Comes along through a nice choke, a nice smoothing choke, and it comes onto the anodes of these 2 output valves, or these 2 tetrode valves. Like I said, they're a big, powerful, beefy valve. They're the ones with the top hat things on top of the... I'll show you in a minute in the back of the unit anyway. And how it works is, this other valve down here, this other diode valve is actually, it's in reverse, so it produces a negative HT voltage. So you've got a positive HT voltage applied to the anodes of these valves here. You've got a negative HT voltage down here, and you've basically got a resistor here. And what it does is this resistor goes between the positive and the negative high tension voltages. And it has basically it produces a control voltage on the grids here, which can be varied positive and negative, which basically limits the flow of the electricity from the anodes to the cathodes on these 2 valves, which then goes out to your HT positive, and obviously your negative is your ground connection. That's basically how it works. And at first I thought the fault might be that someone had been messing with that. There's a little preset there to trim it all up and get everything nice and accurate. That pot there is your big pot on the front of the front of the unit, and that pot there is, if I just show you on the actual unit itself, it's that pot there, which is 100k. I've measured that out, and it's 100k. So I thought, I wonder if something's happened to the resistor that feeds that, which is the 10k. I've tested that, and that's fine. So what my thoughts was, I wonder if something's happened to the negative bias to these valves. And basically, so what I've done is I thought, there's not much. Let's just go back down onto the circuit diagram. There's not much really between the rectifier valve there providing this negative bias and the actual control, which is down here on the actual unit. If we look back at the circuit diagram, all we've got is we've got a 47k resistor there, we've got a couple of capacitors, and then we're straight onto that control there. Now I've tested the control, and the control meters out okay. And I've tested out these capacitors here, and they read as capacitors. They're not dead short or anything, because if one of them shorted, obviously it'd pull that negative HT straight to ground, which obviously then wouldn't drive the rest of the circuit. But you'd expect that valve to complain at that and start flashing over if it's pulling its output straight to ground like that. They don't like it, and they complain by flashing over and doing all sorts of other nasty things. So that only leaves this 470k resistor here. and this is great about this chassis, is absolutely everything is labelled. Now that 470k resistor is R2, and if we look on the chassis here, literally everything, all the resistors, all the capacitors are all labelled. It's actually etched into the metalwork. So R2's this component here, which is a 470k resistor. Now we get our test meter. You can see that on the shot. Let me bring it down so you can see the test meter as well. If we go onto this 470k resistor here, there's nothing there. You can see that. It's not reading. There's it's open circuit basically. So with that open circuit, what I think's happening is that then, with that being open circuit, it's cutting off the drive from this negative bias up here. So that is basically being driven positive all the time because it's got no negative bias on it there, which is obviously driving output to the grids there, which is turning the valves on and giving us that 400 volts HT here. So I think all I need to do is basically replace that resistor there, and we'll give it another test and we'll see whether it's going to work then. So I will. I think I've got some 470s. Yeah. Now these are. I think these are 2 watts. I think we've got some 2 watts in here. That's probably a 1 watt that's in there. Obviously, the more modern resistors, they got a fair bit smaller, but that's a 2 watt modern resistor. Like I say, I think that's probably a 1 watt. It could be a 2 watt that's in there. So we will we'll get that out of circuit. I think I'm going to actually just cut it out, and then I can wrap the new leads round the old like that and make a good joint and solder it in like that. I don't think I'm going to try desoldering these because they look very, very well wrapped up, and you can actually do more damage than you do good sometimes. We'll get some, and there's still plenty of meat around them to wrap the new connections around, so that's not a problem. We will snip this off nice and close. Excuse me, my head's getting in the way of the shot here. Of course, what we should do now is test this out of circuit, just to make sure, absolutely sure that this is the problem. We will. I don't know. It does look like it might have been overheating. That. Let's test it out of circuit, and we'll see. We'll see what the meter says. Yeah, that's a dead one. You can see absolutely nothing on that at all. So let's install this nice shiny new one. Have to bend that round a little bit. Hook that on that side. Bend it round this side like that. I'll get some pliers on that. Knock a load of crap into the bin. Just bend that round like that. We'll solder that side in position, and then we can get onto the other side and we can get that soldered up nicely. So let's go on here. Give that a solder like that. Now we'll just give that a sec to cool. That should be alright now. We can get in, we can get hold of that tail on the other side and pull it round. Bend it up. Come on. Like that. Oops, you can't see what I'm doing here, can you? Sorry about that, folks. Right, so we've soldered that one side in there. Just bent that side round, so we'll just get in there and solder that into position. Sorry about my big head getting in the way, but I've got a little seat myself to solder it. There we go, that's it. That's that side soldered in. And we may be lucky that literally all that was wrong with this was one burned out resistor. So we'll give it a try now anyway, and we'll see what we get. I won't bother putting it back together because we know it's not going to produce any sparks, we don't think. Anyway, it's on a rubberized mat, so it's not a problem. I think what I'll do is I will connect my test meter. Let's get you down so you can see what's going on here. What I think I will do is I will connect my test meter up, and we can monitor what the real high tension is rather than just relying on the meter there. Don't worry, that's still on resistance range. Let's put that round onto the 500 volts range. We will make sure that's down to 0. Switch on, and we'll switch the unit on. Hear the transformer come up, but we'll see whether this stays down at 0 now. Well, I think that had risen up before now, hadn't it? Shall we try increasing the output? Shall we see if we can go up to say 100 volts by turning this? There we go. Bit high. There we go. We're on 100 volts there. The scale on here is a little bit off, I will say that. I think I'd always use this a bit. I would never rely on the scale that it's showing on here, really. I'd always rely on a meter. Let's try 200. Let's see what it says 200 on the scale on here is compared with the meter. You see 200 on here showing us about 240 on there. There may be some calibration on it, I'm not sure. I can't see anything really on the circuit that should do it, unless well, that's back right off, so I think if I increase that, it'd decrease it. I think it wouldn't cause any problem with the scale though, because the scale's right on the output of the unit, so I think we probably will have to just settle. Let's turn it right down to 0 again. So you've got a fair bit of perhaps the scale just needs adjusting slightly, but it's definitely, if we can see there, it's definitely 100% working. In fact, I'm just going to set up a quick little demo showing you actually using this thing, so I'll be right back in 1 minute. Okay, I'm back, and as you can see I've got it all put back together. Now I have had a little play just seeing if I could get a bit better accuracy on the meter. It's not perfect, but I've got it a little bit better than it was. And there's probably a few resistors inside which have drifted, and that's what's throwing it off. So I will go back and address that again in the future, but at the moment, like I said, I'd always use it with a voltmeter anyway, a modern voltmeter, because it's not the most accurate of things, these analog meters. These are so cheap nowadays. I mean, if it weren't such a beautiful unit, I'd even consider putting a modern digital meter in there to replace that. But it's too nice a unit to start hacking about to do anything like that with. Like I said, the only thing I've done is change that power connector and replace that resistor to get it actually working. And on the subject of the power connector, I did what one of my viewers suggested, and put a couple of turns of tape around the cable and then retighten the grommet on it, so it's good and tight now. It's not going to push into the unit. I mean, I put them cable ties around it to stop it pulling out, but with a couple of turns of tape round it and then just crank that down on the stuffing gland at the back, it can't push in or anything, so that's completely perfect now. So yeah, what I thought we'd do is we'd have a quick final play with this thing and just a quick demo. So what I thought I'd do is I'd hook this up to it. What we've got here, let's get you down. Oops, that's no. I think I'm zoomed out as far as I can get. Yeah, that'll have to do. So anyway, what I was going to say, what I'm going to do is I'm going to hook this up. What we've got here. Now this is the basically this is the famous one valve wonder amplifier that we've been going on about. This circuit here is basically what Dan Set used in a few of their players. Just I've not put in the tone control or the volume control because I don't need it for what I'm playing with at the moment. But this is just this is basically the simplest valve amplifier really you can come up with. It's just an EL84, just a single EL84 valve connected up. But I thought it'd be a fun thing to show this unit actually working with, and cause I had the circuit built up anyway because I've been playing with that and some MOSFETs. That little cartridge project. So this is basically the amplifier I've been using to test that with. So we'll get it. All we've got here is, I think we're going to have to use some extra bits of wire to get this all to connect up. But basically, what we've got is we've got my little MP3 player down there, which I'll get that switched on and started up. That'll take a second or so to boot up and what have you. So we've got that providing a music source. So this isn't going to be very loud because we are driving a very small signal into this. But it's just literally it's just to demonstrate this unit working. So we've got the low tension for the valve filaments connected up there. This wire here is for our high tension, and this is our ground wire here. So these are a bit short. Actually, I was messing about with this on my own little home built unit I built years ago. And the way that the connections worked on that, I didn't need the wires very long. Obviously on this I am going to need them a bit longer, so we'll just have a quick squiz through. Well, this will do. Yeah, I've got a bit of wire there. Let's see if I've got a bit of wire here. Let's trim that off. That's the tablet booted up. Right, so this is the high tension minus. This is our negative. We'll just bend that round there. We are off, aren't we? Main's off, and we're right down, so there's no HT on here. I'll put that round there, but I do want to connect the meter up as well. So what I'll do, just put the meter on top like that. We can pinch both. I am going to make up some proper connectors with the proper terminals on them, but I haven't done it yet, so I think I've got some in here. Have I got some? Yeah, I've got this type of connector, which is what we should really be using. In fact, I've got a few of them here. Let's at least for the high tension one, I think they're easy enough to use, aren't they? How did you get in there? Ah, you pull that ring off. And then I think these separate yet. I'll show you meant to solder your wires to these, but this is literally just a quick little test, so we'll just be ghetto. We'll just twist it on like that. This isn't staying like that. I will say that now. Oops. Right, just this is going to be fiddly. There we go, that's together, and then you slide that back on there to lock it together. That's made. That's going to be our high tension one. We'll just twist that on there. So this is very, very lash up. So that's on there. We'll connect that one to there. That's our negative. Like that. Let's see if we can get this and make sure that them two don't touch together, because that would be bad. And the probe into that connector there. Hopefully we can do that. Yeah. Okay, so we can monitor the high tension on the proper meter there. They're both connected. We'll make sure that them two wires don't touch. We'll make sure that none of the other wires that we've just twisted together touch anything they shouldn't. We'll put that over there like that. Them two aren't going to touch. Now we need a valve to go in there. I've got a EL84. Well, it's not actually an EL84. This, it's one of the Russian EL84 equivalents. I quite like these because they're dirt cheap, and they sound decent and they don't seem to fail. I've never had anything back that I've fitted one to anyway. Right, there we go, that's in the socket. That's everything connected up there. That's everything connected up there. Let's switch on. Got our voltage right down. We'll switch on. We'll see if the valve heater glows, which hopefully it should. Yeah, the valve heaters are glowing in the valve. Don't know if you can make that out on the actual. Can you make that out? Let's zoom you in perhaps a little bit. Yeah, you can see that the valve heater there is glowing. Right, so let's we'll start playing some music. What's playing from the? Oh, that's actually playing through. Right. If we increase the high tension. There we go. Just that down, that sets the wrong thing on the meter. There we go. So we've got that showing 200, it's about 230 volts. And that's the valve amplifying it. That's about as loud as this tablet can actually come out. Trying to add a little bit more to it by about 250 volts, 240 volts DC is pretty good for these EL84s. They can run a bit hotter. But that at least shows that the power supply is working. It shows that the smoothing in the power supply is working absolutely perfectly. So you can hear there's absolutely zero hum there. But let me just stop the music. If you can hear, there's no hum there at all. If I disconnect that, so that's just picking up all the interference. If I plug it back in though, you can see absolutely zero hum. So the smoothing in the actual power supply is really good. Actually doesn't sound bad at all, just that one valve hooked up like that. It's just a shame it's no louder. Anyway, I'll better stop that. Anyway, like I said, I'm going to leave the video there for now. Like I said, we've actually got the unit working. It's certainly going to work well enough for my needs anyway. So I hope you enjoyed that little oops, excuse me. I hope you enjoyed that little video and the update on this. So thanks for watching and goodbye.